Hello everyone. In today's video lecture, we'll be learning about attenuation. So, what is attenuation? Attenuation is a type of transmission loss. Okay, this is a type of transmission loss that happens when a signal is being transmitted from a transmitter to a receiver. So, what exactly happens is that when the signal is being transmitted, there is a change in intensity of the signal that is being sent. So, this is basically because of the attenuation. So attenuation is usually measured with respect to the distance that is being traveled by the signal from the transmitter to the receiver. And attenuation is measured or expressed in terms of decibel, that is dB. So you can see from the figure what happens to a signal when it is being transmitted and the effect of attenuation on a particular signal. The original signal you can see of high peaks, the signal that is being attenuated, there is a change in intensity or the amplitude of the signal. So there is the signal gets attenuated. So attenuation is basically a transmission loss. Transmission loss is nothing but the loss that happens when a signal is being transmitted from a transmitter to a receiver in a particular distance. And attenuation basically brings out a difference in intensity or a reduction in amplitude of the signal, as you can see from the figure, and attenuation is expressed in decibels. Okay, now you can see the different terms that are being used for calculation of attenuation. First, we'll learn what is attenuation loss. Attenuation loss is denoted by the letter alpha L, and it is expressed in dB. And alpha L is calculated by 10 log Pi by P0, where Pi is the input power of the signal and Pout is the output power of the signal. The attenuation loss is always expressed in dB. Next is attenuation coefficient. Attenuation coefficient is denoted by alpha. Attenuation loss is denoted by alpha L, and attenuation coefficient is denoted by alpha. Attenuation coefficient alpha is always expressed in terms of length. Length is the distance traveled by the signal from the transmitter to the receiver. Here it is denoted by the letter L. So attenuation coefficient alpha is always expressed in dB per kilometer because we are considering length here. And the attenuation coefficient alpha is given by 10 by L log Pi by P0, where L is the length of the fiber or the transmission distance. The length of the fiber is actually the distance traveled by the signal from the transmitter to the receiver. Okay, now we can see the different factors that leads to attenuation in a fiber. So those are material absorption. In that there is intrinsic and extrinsic, then linear scattering losses, then non-linear scattering losses, then stimulated Raman scattering losses, fiber bending losses, and dispersion. Inside dispersion we have chromatic dispersion, material dispersion, waveguide dispersion, intermodal dispersion, and polarized mode dispersion. We will be learning in detail about each of these factors in detail. So the first factor that leads to attenuation is material absorption. So from the word material, what does it mean? So it is something related to fabrication. So here the material absorption is due to the fabrication process in the optical fiber. Okay, so material absorption occurs due to some of the defects in the materials that is being used in the fabrication of optical fiber. So because of the materials that is being used for the manufacturing of optical fiber, there is certain amount of absorption that is coming with it. That type of absorption is called material absorption. So the different factors that contribute to material absorption are: the first one is intrinsic absorption, the second one is extrinsic absorption, and the third one is absorption due to atomic defects. Extrinsic absorption is mainly due to the basic atoms that are inside a fiber material. Okay, so related to the basic atoms in the material, there is some absorption, that is intrinsic absorption. Extrinsic absorption is mainly due to the impurities. That is, we dope certain impurities to our semiconductor devices. Due to that impurities, there are certain absorptions that happens. So that type of absorptions are called extrinsic absorptions. And the last one is due to the atomic defects in the glass material. There is some absorption. So these are the three main factors which are responsible for material absorption. The first one is intrinsic absorption. The second one is extrinsic absorption, and the last one is absorption due to the atomic defects. So next one is intrinsic absorption. The intrinsic absorption is mainly due to the materials that is being used for the fabrication of optical fibers. As you all know, in most of the cases, pure silica glass is used for the fabrication of optical fibers, and pure silica glass has relatively low intrinsic absorption. So from the figure, we can see three windows of operation of optical communication. As already discussed, we have one first window, second window, and third window. The first window is at the wavelength of 900 nanometer. The second window is at the wavelength of 1330 nanometer, and the third window is at the wavelength of 1500 nanometer. So you can see you can see ultraviolet absorption and infrared absorption. So from the figure you can see that intrinsic absorption is prevalent at ultraviolet region and as well as infrared region. So you can see from the figure that there is a dominance of intrinsic absorption across the ultraviolet region as well as the infrared region. So this intrinsic absorption mainly occurs between the interaction between the silicon oxide band and the electromagnetic field of the optical region, which produces intrinsic absorption. Okay, the next topic is extrinsic absorption. The optical fibers are manufactured using the melting technique. So during this process, the metallic ions like the copper 2 plus, the iron 2 plus, and the nickel 2 plus gets deposited. As a result of these deposition, impurities comes, and this impurities causes absorption of incoming photons, and this process is called extrinsic absorption. And another factor that leads to extrinsic absorption is the SiOH bond, which forms from the OH ions and which has a fundamental absorption at 2700 nanometer. So the formation of OH ions has also to be reduced to prevent extrinsic absorption, and this SOH bond has fundamental absorption at 2700 nanometer, and its harmonics are present at 1380, 1250 and 950 nanometer, which also produces extrinsic absorption.